Well, question number 5 says the weights of the green apples sold by a shop are normally distributed with mean 90 grams and standard deviation 8 grams. Find the probability that a randomly chosen green apple weighs between 83 grams and 95 grams. So the question is about normal distribution, and we know how to write the parameters of normal distribution. Let us write x belongs to normal distribution, and the parameters of normal distributions are mean as well as variance. How much is the mean? Mean is already given, it's 90, and variance is nothing but the square of standard deviation, which is 8. So it is 8 squared. Well, we have written the parameters. Now we are going to find the probability of x, sorry, not x, they have told that the weight must be between 83 grams and 95 grams. So more than 83 but less than 95 grams. Well, after that we will standardize the score. So our z score is going to be 83 minus mean is 90 over standard deviation, which is 8. Then z less than 95 minus mean is 90 over standard deviation, which is 8. Well, after that, let us see our z score. It is going to be negative 7 over 8. Probability of negative 7 over 8 less than z less than 95 minus 90, so 5 over 8. 5 over 8. Well, if we divide 7 by 8, it is going to be negative 7 over 8 is probability of negative 0.875. 0.875 less than z less than, if we divide 5 by 8, it is going to be 0.625. 0.625. Well, then we will have to draw the normal graph. Let me show you where to draw the graph. Yes, I do have space just below this. So our z score is, look, we are going to find the probability of, suppose this is our graph, normal graph, and the mean value is 0, and here it is negative z score, and this one is positive z score. Okay, how much is our negative z score? Negative z score is our negative 0.87. Let it be negative zero point 0.8 over here. Okay, and positive zero point 0.6. Let it be positive zero point 0.6 over here. Well, then they have told to find more than 875. That means more than 8 but less than zero point 0.6. So our probability is this region. Okay, this is the probability, this is the region we should obtain, this probability of this portion. Okay, in between this, so this portion is to be obtained. Okay, this is our probability to be obtained. Okay, for this what we can do, let me draw another graph, normal graph. We require this mid portion. Look at this. So we can, for this middle portion, what we will do, we will just, let us write here our z score is 0.6. Okay, then we will get the probability of whole of this. No, not this way. Yes, whole of this. If we get whole of this probability, from which we will subtract just this portion. Look at this here. The probability z score is negative 0.8. Now from whole of this, look at this red portion. Whole of this is the probability when that is z score is zero point 0.6. So from whole of we should not forget that this is our region. Okay, this is our region. So for this region what we will do, we will subtract the left part. If we subtract this part, look at this portion, or let me use blacking. So we are going to just subtract this portion. If we subtract this portion, then we will get the required probability. I think you have understood the points I have noted down. We require, once again I am showing that we require the probability of this portion. Okay, for this portion, first of all we will find whole of this probability. Okay, we will get whole of this. After that, then we will subtract this black part, this portion. If we just subtract this portion, then we will get our required probability. Well, then this middle part, I mean this portion right side, is our probability. So how are we going to write? We are going to write, yes, we are going to write probability of, from when z score is zero point 0.6, we will write z is less than 0.6. 0.6 how much? 25. From which we will just subtract this z score when z score is 0.8 minus z score is less than negative 0.8. We will just subtract this portion as I have made dark. So we are going to write z score less than 0.625 minus, now look at this, there is no probability given for corresponding negative z score in the probability distribution table. Always the z score is given positive. So how can we do this? We will just do the vice versa. If I draw one more figure, then let me see whether I do have space or not. Yes, I do have space over here. So what do we need? We require this portion less than, here is negative 0.8. Okay, negative 0.8. We require this portion. So as the curve is symmetrical, what we will do, we will just, we require now this portion. Look at this. This is 0.8 and it is 0 over here, 0. Then as we need this portion, this tiny portion, for this what will we do? From whole of this we will subtract this portion. Yes, now we will take the probability when z score is 0.8 from this. From whole, if we subtract this portion, then we will get our probability of this tiny part. This tiny part can be obtained from whole of the probability if we subtract the left part when z score is 0.8. So it's all the same. Okay, because the normal distribution graph is always symmetrical. Well, I think you could understand my point. So what are we going to do? We will just going to subtract from 1. Okay, from 1 we will subtract the corresponding z score, z less than 0.8, because 0.875, sorry, it's not 8, it's 875. So why did we do so? because we know in the probability distribution table all the corresponding probabilities given are for positive z-score. That's why we can convert the z-score from negative to positive, and this is 875, 875, 7 as well as 5. So finally our z-score is going to be, or or probability of z less than 0.625 minus 1 plus probability of z less than 0.875. Now using the probability normal distribution graph, manually we are going to write this. When our z score is 0.625, then what is our corresponding probability? Let us use the probability distribution table, I mean normal distribution graph. So our let me show you. Okay, on this page we can write here. No, we can write just over here. Okay, so let me show the image. Yes, this one. This one is our normal distribution graph. Yes, this one. We have chosen this. Let me. So let it be our normal graph. Let me remove the unnecessary one. So this is our normal distribution function table. Okay, how much was our z score? Our z score was, let's have a look again. Our z score was 0.625 and 0.875. Okay, 0.625. First of all, 0.625. Let me show you 0.625. Look, here it is written zero point 0.6, then 2. After that there is 5. Where is 5 here? Here is 5. Then if we find the row, this row is this one. How much is this? And from this we'll have to, this is from 16. Yes. So this is our corresponding probability for this. It will be just over here and there, row and column. After that we will add up this 16. So let us see how much is this. 0.7324, 0.7324, to what we will have to add up this 16. If we add up 16, it is going to be, what is it going to be? 0.7340. So first probability is 0.7340. Then the next z score, was 0.875. Look at this, it is 0.875. This is the other z score. So first probability is 0.875. Okay, Now for 0.875, where is it? 0.875. 0.8 is over here. Let me use a different ink. 0.8 is over here. Then 7. 7 is over here. So 8, 7 and 5 is, it's all the same. Okay. Let me erase the previous one. This is unnecessary. Well, so 875, this is the column, this one. So this one is our probability. Then we will have to add up in the fifth column. Which one? This one. So it is 8.8078. It will be 0.8078, to which we will multiply, we will add up. How much is to be added? It is 14. 14 should be added. 14. If we add up, it is going to be 78.92. 8092.8092. So what are our corresponding probabilities we have obtained? First probability is 0.7340. Second one is 8092. So let us write this. This is for the corresponding z-score of 7324. It is 7340. Sorry, it was 0.625. First one was for 0.625 and second one was for 0.875. So first probability is 0.7340. First probability is, yes, first probability was 0.7340. 0.7340 plus 1 minus, when z-score was 0.875, our probability we have obtained was 0.8092. 0.8092. Now if we calculate this using our calculator, we are going to get 0.7340 plus 1 minus 0.8092 equal to, it is 0.5, 0.5432. So if we round it up to three significant figures, it is going to be 0.543. So that's all about finding the probability between two z-scores, or between two standard deviations. And once again, in brief, I am telling for the last time that they have told us to find the probability of the scores in between 83 and 95. So for that, corresponding z-score is negative -zero point 0.8 until 0.6. That's this, for this middle portion, this was our probability. Okay, for this, what have we done? We have just got whole of the probability, then subtracted. So we have, from whole of the probability, we have just subtracted the left part, as I have made it black. Okay, this black portion has been subtracted from the positive z-score. And for any negative z-score, we just have to shift the graph. We should take the right portion. Okay, from 1 we just subtract the left portion. And you have understood how to find the probability of such cases. Let's move on to question number B. Question number B says, the next question is, the shop also sells Red apples, 60% of the red apples sold by the shop weigh more than 80 grams. 160 red apples are chosen at random from the shop. Use a suitable approximation to find the probability that fewer than 105 of the chosen red apples weigh more than 80 grams. So it is very clear that there is a clue word in the question. The clue word is approximation. So whenever the word approximation includes any question, it means the distribution is given in binomial which is to be converted to normal distribution. So we are going to write that it is given in binomial distribution, and the parameters for binomial distributions are NP. N is the total number of experiments. So total there are 160 apples. So 160, and the second parameter for binomial distribution is P. Probability is 60%, means 0.60. Then this distribution should be converted to normal distribution. Now X belongs to normal distribution. For the normal distribution, the parameters are mean as well as variance. So mean is NP. NP is equal to mean. So we can write mean is equal to N into P. And variance is equal to N into P into Q. Into Q. So N into P. N is 60. This is, we can write here N. This is N and this is P. So NP is 6, 16 and 96. So it is going to be 96. And another one is variance. Variance is NPQ. NP, let me erase this. It has got, okay. NPQ. NP is 96. If we multiply 96 by Q is actually 4. If P is zero point 0.6, so Q is 0.4. If we multiply 96 by 0.4, it is going to be 38.4. So this is what our normal distribution. Now they have told us to find probability of fewer than, look at this, the fewer than 105, fewer than 105 of the chosen. So X is less than 105, but we should not forget that we are converting a binomial distribution into a normal distribution. Binomial distribution is applicable for discrete random variables, whereas normal distribution is applicable for continuous random variable. That's why from converting to discrete to continuous, we'll have to do continuity corrections. So it is 105. So from 105, less than 105, we'll have to balance by adding or subtracting 0.5. So it is going to be 104. So please don't get confused with this concept that continuity correction should be done when you convert a binomial distribution into normal distribution. Okay. Well, then we will find the z-score. We'll standardize this equal to probability of z less than 104.5, 104.5 minus mean value is what, this is our mu is 96 over standard deviation is square root of the variance is 38.4. So it is square root of 38.4. Well, then our z score is going to be, z is less than, it must be positive, less than 104.5 minus 94, that is 8.5 over square root over 38.4. It's 1.7372. 1.372 is our z score. So for this corresponding z score, we will have to find corresponding probability. Okay. Well, we are going to find, let us use the normal distribution curve because I find it comfortable to use the normal distribution graph, normal distribution function table for finding any corresponding z score or probability. Okay, our z score is 1.372. Let me bring the, yes, let me bring the normal function table, that is normal, yes, this one. Okay, let it be zoomed out. Our z score is 1.372. So 1.372, 1.3 is over here. This is 1.3. Then 7 is over here. After that there comes 2. Okay. So 1.37, the column is, this one is the column. So this is our probability. Then with that we will have to add up this one. These three should be added. Okay, so if we add up 91.9147, if we add up 3.003, so it is going to be 0.9150, 0.91 and 50, 0.9150. So let us write the corresponding probability for the given z score is point equal to point, our corresponding probability is 0.9150. 9150 is the probability when it is approximated. And I think you have understood, it's not difficult at all. Actually, whenever approximation word is included, then the distribution is given in binomial manner, which is to be converted to normal distribution. And whenever we convert a binomial distribution to a normal distribution, then we should not forget about the continuity correction. Continuity correction must be kept in mind. Okay, this one, because binomial distribution is applicable for discrete random variable, whereas normal distribution is based on continuous random variable. So continuity correction is a must. Let me show you the previous one. Yes, this was the previous one. I think I tried my level best to explain every tiny part of the solution. If it is beneficial to you, please pray to Almighty Allah for the welfare of mine and for the welfare of the whole humankind. Fi amanillah.